Here's your homework ANCOVA. Again, I'm going to go as fast as humanly possible, but there's our ANCOVA. The C stands for covariate. We're going to run this in SPSS, and again, the C stands for covariate. Okay, a covariate. Let me try to explain to you what a covariate is in statistics. You remember the two-way ANOVA, the factorial ANOVA, where you have two grouping IVs or more, one continuous DV, and you would run your two-way ANOVA and you would either get a significant F or not, right? So is the first IV affecting the DV? Is the second IV affecting the DV? That's a standard two-way ANOVA, but could there have been something else affecting what happens on the DV? There's always something that could affect your results of the DV here. So that other item is what comes into play when we start doing the two-way ANCOVA, right? The unknown effector. Okay, that's what we call the covariate. So in other words, there is another variable that wasn't in your original study, but you collected the data for. Usually it's demographic data, like age or social economic status or something else. There are other things that could be covariates. But this third variable here is somehow affecting the DV, either through one of the IVs or both of the IVs or all by itself. Okay, so this is what we call a covariate. It is the same thing as a moderator. It is affecting the relationship between your IVs and your DVs. Okay, so remember that. This third variable, IV, has something to do with the influence of the DV. Very important. Your covariates always have to be scaled, continuous ratio numbers. In other words, it's not a grouping IV. This cannot be a categorical variable. Covariate has to be a continuous regular counting number. And of course, the ANCOVA has its own set of unique assumptions. Okay, so assumption number one, measurement of the covariate. The data had to be recorded before any analysis was run. That's why it normally comes from the demographic side of a questionnaire or survey. And ours was, we have the data already recorded before we ran any analysis. Assumption number two is the reliability of the covariate. That means, was the data correctly and accurately recorded? And we're going to assume that it was. Okay. Number three, the correlations of the covariates. It has to be less than 0.0, less than 0.8. Okay. So I'm going to do this one backwards. We're going to run the ANCOVA first to determine which one of these variables is a covariate before we do all this testing of the covariate relationships and stuff. Okay. So again, we're going to identify the covariates when we run the ANCOVA and then work backwards to check the correlations between the covariates, because if there's only one covariate, this assumption does not apply. Assumption number four, linearity between the covariates and the DV. Same thing. I'm gonna determine which of the variables is a covariate before I test this one. Okay. And the same with this one, homogeneity of regression slopes. So let me start with the ANCOVA. Okay, so let me switch over to SPSS. So I took the data, I put it into an Excel. Let me show you the variable view. Okay, that's what it looks like. Right, the following variables are categorical: gender, group, prep, whether they got the prep or not. Okay, and back to gender, one is a male, two is female. And whether they had the prep course or not is one that they did, two was a no. And everything else looks like a scaled variable. Okay, so first thing I'm going to do is I'm going to check for normality. I'm going to do it a little bit different this time. I'm going to go to Analyze, descriptives. This time I'm going to go to frequencies. And I'm going to do all of the scored variables, the scale ones. Okay, you do not do frequencies for categorical variables. It just doesn't make any sense. So let's look at the stats. And I always like the means to see how skewed or kurtotic it is. Charts, histograms, that tells us how normal it is. Don't need the format, click OK. Okay, so here's the mean of all the ones we put in there. Age, fear of stats, pretest scores to exams. No missing data. Skewed. Okay, so age is a little bit skewed. It's also a bit kurtotic. So age might not be normal, but again, the ANOVA and ANCOVA are very robust. So that means you can sometimes get away with bad data. Okay, frequency tables, don't need that, don't need that, don't need that. Histograms, age. Yeah, this is pretty skewed and kurtotic for age. Fear of stats. Not bad, not perfect, but relatively normal. Pretest scores. Same thing, it's not perfect, but close enough for government work. And the last one is their exam scores, and again, that is relatively normal. So the normality seems good to me. Okay, I'm going to run just a regular two-way ANOVA first without any covariates. I'm going to show you what the covariate does for you. General linear model, univariate. So our DV is stat scores, our IVs are gender and prep. Model. Plots, we should probably put the plots up there. Because we only have two levels, we're going to get a lot of X's. Options, we always look for descriptives, effect size, power, homogeneity. Am I forgetting anything? Yeah, I should do it for now. Okay, so here's a two-way ANOVA without any covariance. There's our groups. There's our means. Levine's test did not violate the homogeneity of variance. And here's our money box. Oh, baby. So yes, there is a significant difference, but look how small that F is. It's 3.4. The significance is 0.03. So there is a significant difference, but it's not very significant. You see that? You see how small that F is? And the partial eta squared is only about 28%. So with this model the way it is not a excessively strong model. There is a significant difference, but it's not an excessively strong. And gender, there was no significant difference. Prep scores, no significant difference, but there was an interaction between the males and the females and whether they took the prep test or not, or the prep course or not. So now let's run the ANCOVA with the suspected covariates. ANCOVA time. Analyze. General linear model, one variate. So we're going to put in age, fear of stats, pretest scores. We're going to put them in the covariate box. We're going to check them and see. Everything else should be pretty much the same. So here's our new ANOVA with covariates called an ANCOVA, right? We're looking at something that might influence the relationship between the IVs and the DVs. So we got the same numbers, right? Same numbers in each group. Same means. Homogeneity variance should be the same. And then here is our source of variance table. Okay. First thing I want you to notice is look how big the F changed. Before it was 3.4, now it's 13 something. Okay, so it literally quadrupled the strength of your test. And you definitely got a significant difference in there, but look at the partial eta squared. Bam, you jumped from 28% to about 78%. So again, you tripled the accuracy of what you were measuring here, which is pretty darn impressive. I am impressed, aren't you? Ha. So don't look at the intercept, but age. Right off the bat, age is not a covariate. See the significance? The F score is practically 0. The significance is practically 1. So age is not a covariate. Fear of stats, same thing. Significance is greater than 0.05. So fear of stats is not a covariate. Pretest scores, ding, 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 that's your winner. So in other words, the pretest scores are a good indicator of how they're going to end up on the DV. That kind of makes sense. So if somebody scored high on a pretest score, they should have scored high on the final exam scores, and vice versa. If they scored low on a pretest score, they should have gotten low on the DV. So this is the covariate. There's only one. It's the pretest scores. But let's continue. So was there a main effect of gender? No. Okay, didn't matter between the genders. Did it matter whether they got the prep test or not? Not really. Close. Okay? But according to this, it was not significant enough. And was there interaction between the gender and the prep test or not? Yes. Okay. So since there was interaction, we would not look at the main effect of gender or whether they took the prep test. What this is telling us is one of the genders and one of the groups that they either took the test or not is a significantly different DV scores. Okay. So example, it could have been like the females who had the prep test scored much higher than the males that did not have the prep test. That kind of thing, okay? So we only have one covariate, and that was the prep test. So now I'm going to go back and check all the assumptions strictly for the prep test. Okay, so hold on. Okay, we're going to check the linearity between the covariates and the DV. We only had one covariate, so let's check it out. First thing you're going to do is go to Graphs, Legacy, Scatter / dot. You want a simple. You're going to define it. So your y-axis is your DV. That's our state exam scores. And our x-axis is going to be our covariate, which was pretest scores. We can only do one IV at a time, so let's do gender, and that's what you put in your set markers by. Let's click OK. We should get a nice graph. There's our graph. That's kind of linear. There's a trick here. You just double click on it. You can put the line in there, and it will give you the R squared, which is 0.257. If you took the square root of that, it would be like 0.52 or 3 or something like that. That's a relatively good correlation, right? 0.5. So we do have linearity for the males and the females. So let's go ahead and repeat it. This time we're going to do it with the prep testers or not. Okay, so so we kick out gender, get out of there. Prep class or not, hit OK. And there's our linearity there. Again, we'll click on it. Come on. We'll add a trend line. And we get relatively the same thing. So we are good to go on linearity. I'm going backwards a step. Assumption number 3, correlations of the covariates. Since we only had one covariate, we do not need to worry about this assumption. Okay, so assumption number 3 is good. The linearity is okay. It's about 0.5. R equals 0.5, so that means it's relatively linear between the covariate and the DV at the different levels of the IVs. So now we're going to do homogeneity of regression slopes. All right, let's get back to the SPSS. All right, to check for the homogeneity of regression slopes, we're going to go back to the general linear model, analyze general linear model, univariate. We're going to put our DV in the DV box, fixed factors in the IV box, covariate. So we only have one covariate. So let's take out age, fear of stats. We're going to go to the model button. We're changing this one, custom. We want the interaction. Okay, we're going to put gender in, prep or not in. Now this is where we got to do the interaction. You got to pick gender, control, pretest scores. That's going to be an interaction. And then we're going to do group, control. So they both have to be highlighted there. Click them both over. And I think we're good to go. And click OK, and we should get this box. Okay, it basically just ran another ANCOVA for us, but we're just going to look at this box right here. Okay, very, very important. Strictly for the homogeneity regressions assumptions, the only thing that we're going to look at is the interaction terms. Okay, we do not want significance. All right, so the interaction between gender and pretest, no significance. Interaction between group or not, no significant difference. Okay, so therefore we did not violate the homogeneity regression rules. Okay, I'll say that again. Assumption number 5, when you run this second ANCOVA, you do not look at anything except for the interaction terms on the test between subjects, the source of variance table, right? And you want these numbers to be greater than 0.05. If they're less than 0.05, that means that you violated the assumption. Okay, so, but we are good to go. Almost done. So now I want to run the ANCOVA strictly with the one covariate general linear model univariate. Okay, so that's good to go, and it should be set. I'm going to switch it back to full factorial, type 3. Click OK. So this is your final product. What's in each group, mean standard deviations, homogeneity variance not violated. So your overall F is huge. Look at that. It's 18. Remember your original ANOVA was 3.4. Now it's 18. Your eta squared is about 75%. So the pretest scores is definitely a covariate. It by itself can represent about 64.5% of the variance in the exam scores. Okay, so it's a very strong covariate. And again, there was no difference between the gender, no difference between if they got the prep stuff or not, but there was an interaction. So this is your final tally right here. So I hope that helped. But just remember, a covariate is anything that could be affecting how the DV turns out. Okay, so I hope it helped. MGZ out.